Good morning, everyone. We're gonna be presenting textile dyeing. What exactly is textile dyeing and why is it important? Textile dyeing, simply put, is just the transfer of color to fabrics to add permanent and long-lasting color to the fabrics. This goes a long way to enhance the outlook of the fabric. This can be done by hand or using machines. There are basically two main types of dyes in the textile industry. We have natural and synthetic dyes. Natural dyes are extracted from plants, animals, and mineral resources, while synthetic dyes are made in laboratories from coal tar or petroleum-based substances. It should be noted that synthetic dyes was discovered in 1856 by a British chemist. Since then, it has dominated the market due to the fact that it has a lasting color and a range of color choices and is also less costly. What's the current situation? The current textile dyeing processes and materials used in the process is environmentally not sustainable. There is high use of toxic chemicals and large amounts of water goes into the process. Large amounts of wastewater is also being generated from textile dyeing, and this causes environmental pollution. Synthetic dyes are mostly used nowadays in this industry. There is about 10,000 different types of dyes in the industry, and about 800,000 tons of synthetic dye is produced annually. Here you find a chart of the classification of various dyes, but I'm not going to go deep into this. If you want to read more about it, you can go to this website to get more information about the various dye types. Synthetic dyes are also being marketed in different forms. We have liquid, powder, paste, or granular forms. There is a huge market for textile dyes, and this was estimated at US $16.91 billion in 2020, and it is expected to rise to 22.39 billion in 2025. Dyeing fabrics basically involves three processes. That's the preparation, the dyeing stage, and the finishing. And in this process, about 2% to 50% of dye is lost during the process, depending on the class of dye being used. These processes and techniques have not really changed much over the past decades. One of the most dyed fabric in the industry is the polyester, due to its attractive properties such as recyclability, cost effectiveness, and others.
We'll be presenting the textile dye and manufacturing. My name is Daniel. The textile dye is considered into two: the natural dyes and the synthetic. Where we have the natural being that of plant, animal, and mineral extracts, whilst the synthetic are made in the labs as well. Yeah, under the natural dyes, we have the animal derived ones gotten from insects and other vertebrates, with carmine from the textinel, the India yellow from the urine of cows, and then we have other insects as they are listed below. And we have the plant derived dyes, which are extract from root stems and leaves. We have some plant like the Himalayan that develops or yields a yellow color, and then we have the brown from the catch trees, and then Kamala trees produces the red color, and then the rest. Yeah. Then we have the last part of the natural dyes, which is the mineral dyes, which we get from, as the name says, the mineral ore, mostly from the petroleum residues as well as the other minerals like the lead, etc., which provides different kind of colors here, as stated. Then we have the synthetic dyes here, which are mainly man-made, derived from the petrochemicals and other chemical processing like the quota and residues of crude oil or petroleum. This can be easily made in large quantities, and we have a lot of toxic materials as the residue from petroleum, especially lead, mercury, copper, benzene, chromium, and the rest here. And the one other significant aspect is its synthetic fiber requires a different kind of dyeing. We're going to have a different type for the copper, different kind of dye for polyester as well as cotton and then nylon. So as stated earlier, the chemicals used in the synthetic dyes produce a lot of pollutants to the environment, especially in that mass quantity, where we have those in the assembly line or the conveyor section having to bear a lot of it when it comes to the pollution they have from the gas pollutions. And we have a lot of this gas which interfere with their health and respiratory problems, especially the sulfur oxide, the nitrogen oxide, as well as the hydrochloric acid, which later on gets to affect them, their lungs, and then causes later illness within them. Then we have the liquid residue as it comes in their waste form, which is measured in per the product produced or kilogram of product produced. So we have some when it comes to the VAT dyes, which requires about 8,000 liters just to produce a kilogram of the dye. And then we have the biochemical oxygen demand dyes, which requires about 25 kilos to produce just a kilo of that dye. And then we have the oxygen, the chemical oxygen requires well over 80 kilograms to provide just a kilogram. So most of the residue then ends up in our body, ecosystem, or water bodies, thereby destroying our ecosystem. Now the last part, which is the solid waste produced from the synthetic, which produces in the form of sludge, acid, and then other process residues, which tends to disturb our environment, thereby seeping into our water bodies and then disturbing our ecosystem.
So we have seen how it's the industry today, but what about the future? Let's talk about how science and technology can dramatically change how this dye industry consumes water, chemicals, of energy. We're going to see different examples of companies that currently they are trying to make and improve in the consumption and sustainability of this industry. We're going to start by Dry Dye, that it's a Netherlands company that tries to change the actual ratio of water consumption for textile. For clothes, there is an average of 200 liters of water per 1 kilogram of textile. So the thing they do, they instead of using deep into water tanks with all the coloring particles, they trying to use supercritic CO2. That is CO2, but applied with high temperatures and high pressures that makes creating a supercritic fluid that it's used for replacing the water. But there is also some concerns about using chemicals as coloring particles. In H&M, they are currently switching from chemicals to biological particles, in particular selecting and growing some microorganisms and optimizes its ADN for obtaining better results. Also, there is a huge concern in the temperature that it's used for this process, and in particular in the UK, Alchemy company, it's currently trying to change the way it's produced all the clothes. Instead of using a mass chain production, they're trying to use just-in-time production with on-demand coloring patterns, and in that way they can reduce the order of magnitudes of the temperatures needed, and therefore saving some energy. In particular, using digital print heads could allow them to reduce its consumption. Finally, Montfort's from the Germany, it's currently trying to recycle all the heat liberated in the production and in that way reducing the evaporation that makes energy losses in terms of this gas liberated, and therefore reducing also the energy consumption. But this is only the beginning because there is plenty of companies that they are trying to currently change the mindset. For example, Siemens in Austria that is using magnetic technology, Superba in France trying to use high pressure for creating carpets, Imogo in Sweden trying to use aerosols, or Baldwin from the paper industry that trying to apply these same techniques into the text. Finally, TS from Germany, it's trying to use all these 4.0 industry technology like intelligence, artificial intelligence.
As the fashion trends continues to change daily, more textiles are produced, dyed, and around 87% end up in landfills globally. More and more chemical dyes are used, and the wastewater ends up in rivers, lakes, and seas across the world. As we have seen in many developing economies, the dyeing process can lead to devastating effects on the nature and human health. Countries such as India, Bangladesh, Pakistan are some of the worst affected. The question still remains, can we find a better, sustainable solution to an already increasing textile demand? Some experts suggest organic dyes, farmed or otherwise. Plants like wood provide green organic dyes. Then again, the question remains, how much land is needed for growing this green chemistry? However, circular economy is the way forward in reducing textile waste. According to a Finnish company, VTT Research Institute, along with Aalto University, suggests that in order to have textile in the circular economy, the history of the textiles should be provided from, from, from the manufacturing to the dyes used. This is important for recycling, especially if decolorization is needed, and also to understand what other chemicals were used during the dyeing process. As of 2025 in Europe, it will be mandatory to have separate collection points for textiles. But it is, in my opinion, that the narrative needed to change the problem of textiles, textile dumping, landfills, is to inform, educate, and help people understand the dangers of the chemicals used in our ecosystem.